Well, hi guys, welcome back to my channel. And as you can see, today we're going to learn gametogenesis in humans. In my previous videos, I've already covered the anatomy of male and female reproductive systems. So today, let us learn about how the gametes for these systems are generated or produced. Now, gametogenesis, when you split this word, it obviously translates into gamete and genesis, which means formation. So the male gametogenesis is known as spermatogenesis and the female one is known as oogenesis. So let us get started with spermatogenesis. Well, spermatogenesis initially takes place in the testis of males, which is in the seminiferous tubules of males mainly, and it takes place in a duration of 74 days, and it is a continuous process, unlike the female reproductive system, which I will be coming to later. So when I say it's continuous, it initially starts at puberty. So when a male attains puberty at around the age of adolescence, the process of spermatogenesis begins. And this is because of the production of a hormone from the hypothalamus of the brain. And this hormone is known as the gonadotrophin releasing hormone. Now, gonads are basically the sex organs of humans. So, gonadotrophin releasing hormones are the hormones responsible for releasing the hormones which control the gonads. And the hormones that control the gonads are FSH and LH, and these are produced by the anterior pituitary gland. Now, FSH is follicular stimulating hormone and LH is luteinizing hormone. Now, how I remember the functions of these are FSH, they act on Sertoli cells to produce factors. So, F for factors. And LH, which starts with L, they act on Leydig cells to produce androgens. Androgens are the male hormones, and Leydig cells are basically the interstitial cells of the seminiferous tubules, which I already covered, so go back to that video and watch it. And these Leydig cells produce androgens, and these androgens are responsible for spermatogenesis. The difference between spermatogenesis and spermiogenesis I will be covering later. Now, let us come to the actual process of spermatogenesis. The initial precursor cells are spermatogonia, and these spermatogonia are basically lining the seminiferous tubules, and they are diploid in nature. Diploid in the sense they are not gametes. They have the complete set of human chromosomes, that is 46 chromosomes, and that's why we denote it by 2N. 2N refers to diploid. Now, spermatogonia, they undergo mitosis. In mitosis, you obviously know there is no reduction in chromosome number. Hence, the products of this mitosis process also contain the same amount of chromosomes, that is 46. So, primary spermatocytes. Spermatogonia undergo the process of mitosis in order to produce primary spermatocytes. And now these primary spermatocytes further undergo the process of meiosis to produce secondary spermatocytes. Now, meiosis, as you know, is a process of reductional division. And in reductional division, there is reduction in the number of chromosomes. Hence, the products, that is the secondary spermatocytes, basically have half the number of chromosomes as of primary spermatocytes. Hence, they have 23 chromosomes. So, you also know that meiosis takes place in two steps, meiosis 1 and meiosis 2. So, secondary spermatocytes are a result of meiosis 1, in which reductional division happens. And you know that meiosis 2 undergoes equational division. So there is no further reduction of number of chromosomes. So 23 chromosomes remain 23 even in spermatids. And now this entire process in which spermatogonia produce primary spermatocytes, which further produce four products of meiosis, which is 4 spermatids, is known as spermatogenesis. Now, spermiogenesis is the production of mature sperms or spermatozoa from spermatid. And now spermiogenesis takes place with the help of factors released by the Sertoli cells, which is acted upon by FSH or follicle stimulating hormone. This basically ensures that the baby sperms, as I would like to refer them as, become into mature sperms. And now this spermiogenesis initially starts in the seminiferous tubules, but it ends in the epididymis. Also, after spermiogenesis, these spermatozoa end up being embedded in the Sertoli cells or nurse cells for nursing or basically nutrition. And finally, these spermatozoa or mature sperms are released by the process of spermiation. Now, let us talk about oogenesis. Oogenesis is the process of producing ova, and it takes place in the female reproductive system. It takes place in the ovary and partially in the fallopian tubes of females. And the time taken is not known. This is because this process is discontinuous. You may ask why. This is because this process initially starts in the fetal female baby. So she is still in her mother's womb. So the process of oogenesis begins right there in the fetal ovary, where millions of gamete mother cells or oogonia are produced in the ovary of the fetus. And these oogonia start dividing meiotically, first initially mitotically to produce millions of oogonia obviously, then meiotically in order to produce the next primary oocytes. Now, these primary oocytes are not completely produced because they're still stuck in the prophase 1 of meiosis 1. So, this process gets stuck in diplotin phase of meiosis 1. And hence, before birth, meiosis 1 does not take place completely. And now these primary oocytes are surrounded by granulosa cells. Granulosa cells are special kinds of cells that surround the primary oocyte, and you will see more of these cells further in this lesson. And now, after being surrounded by granulosa cells, this oocyte is known as a primary follicle. And these granulosa cells are also known as follicular cells. And these primary follicles usually degenerate as you grow up, like as the baby is born and reaches puberty. So by the end of puberty, there are about only 60,000 to 80,000 primary follicles. Now, at puberty, this process recontinues. So, well, I've drawn as a table here the entire process that we discussed till now until primary oocyte. After that, primary oocyte finishes its first meiotic division, which was stopped before birth, to produce secondary oocyte and first polar body, and this is meiosis 1, and it is reductional division. So 2n, that is 46 chromosomes, are reduced to 23 in secondary oocyte. Alright, and now you may ask what happens to the primary follicle. Primary follicles get surrounded by more and more granulosa cells in order to produce secondary and tertiary follicle. And the most important aspect of a tertiary follicle is the presence of a fluid-filled cavity, which is known as antrum. Now, this antrum is filled with a fluid which is known as liquor folliculi. And this antrum, this tertiary follicle now gets surrounded by even more cells to form the Graafian follicle. So more and more granulosa cells form a tight protective cover over the initial primary oocyte. And now the secondary oocyte, which is formed, is surrounded by another layer which is known as zona pellucida. So there is zona pellucida, there is also the granulosa layer cells of the Graafian follicle. These together undergo the process of ovulation, and they get ruptures and releases the secondary oocyte and the first polar body. Now, this polar body is nothing but an extra small body that is produced along with the secondary oocyte. It is not of any significance to the body. It is just produced and it's extremely small. There is a huge variation in size in between secondary oocyte and first polar body. Also, it divides into two other polar bodies by mitosis. Well, that is not important. Let us come to the process of ovulation. So when this secondary oocyte and first polar body are released from the Graafian follicle into the fallopian tube by the process of ovulation, which takes place on the 14th day of menstrual cycle in females, this is the first precursor to the process of fertilization. So now this secondary oocyte has reached the fallopian tube. If fertilized, that is, if the sperm enters this ovum, then the second meiotic division takes place. Then after the second meiotic division takes place, the ova is produced, and this ova is further combined with the sperm to form zygote. And now if this fertilization process does not take place, this ova is released through the blood by the process of menstruation, which includes the breakdown of endometrium. Endometrium is the inner lining of the uterus. So here we realize that the initial meiotic division 1 stops before birth, continues, and the second meiotic division only takes place if the secondary oocyte is fertilized. And now I've also written the ploidy or the haploid or diploid nature of all the cells, so you can note down this table. Well, this was it for today's class. Thank you so much for watching. I hope I can keep you up with the same kind of videos in the coming weeks too. Thank you for being so patient with my videos, and I will be back with new ones soon. Bye bye.